Hello friends, welcome to my space. In this section, we shall be discussing briefly on dimensional analysis. What is dimensional analysis? Dimensional analysis is a method of analysis used by science and engineering students. And what is it used in doing? It is used in checking for unit consistency. It is also used in checking if the formula of if a quantity is accurate, that means it is dimensionally correct. So we shall be looking at briefly the fundamental and derived quantities and their units and how they are used in dimensional analysis. Now for fundamental quantities are quantities that they are basic quantities that are independent. They are simply independent. Now the derived quantities, they depend on the fundamental quantities. And we have about 7 fundamental quantities that we use. Basic. The first one, or the fundamental quantities, we have the first one we call length. Length. Second one is called mass. Thirdly, we have time. Fourthly, we have what we call electric current. Electric current, that is current. We have the amount of substance. Amount of substance. Number 6, we have temperature. Temperature is also a fundamental quantity. And then finally, we have what we call luminous intensity. Luminous intensity. All these are fundamental quantities. Now length L is having units in meters, M. For mass M is having units in grams or kilograms. Time T is having units in seconds. Other times we can use hours, but for SI we use seconds. Electric current is measured in amps, what we call ampere. For short, we write it as amp. Amount of substance designated as N is simply having units in moles. Temperature is having units in K, that is Kelvin. Kelvin, that's K. The luminous intensity is having units in candela. Candela for short, CD. So these are 7 fundamental quantities that are used in dimensional analysis. Now for the derived quantities are obtained from 2 or more fundamental quantities. That means the derived quantities cannot stand without the fundamental quantities. So for derived quantities, we have series of examples. Some examples we have density, we have velocity, we have acceleration, we have force, we have pressure, then we have others, so many, work done, energy, name them. All these are derived quantity. They are obtained from the fundamental quantities, especially the first 3, length, mass, and time. Others are also applicable in most derived quantities, but basically the LMT. Now for density is simply the mass per unit volume. you can see mass is a fundamental quantity. Volume can be obtained from length. So for mass, mass is L. Volume can be obtained, mass is M. Volume can be obtained from length. So the volume is length times length times length. So length times length times length gives us volume. So at the end of the day, we have M divided by L raised to power 3. This is for density. So density depends on each of these fundamental quantities to stand. And the same is applicable to every other one. Velocity, meter per second. So we simply have it as L all over T. Acceleration is velocity over time. So that is meter per second square. So LT minus 2. The likes goes on and on. You can see that each of these, they possess the fundamental quantities. This is for time. So for force, mass times acceleration, pressure is force over area, work done is force times distance. Each of these, they depend on the fundamental quantities to stand, without which they cannot stand. In my next video, I shall be breaking down some of these examples and how they are applied to dimensional analysis. I'm sure we got value from this video. Please do well to subscribe, like my videos, and share for more persons to see. Have a good time.